listeners and viewers. Today in our chemistry class, what we shall be considering is balancing nuclear reactions. Balancing nuclear reactions. In balancing nuclear reactions, there is conservation of mass number, that is atomic mass. There is conservation of mass number and atomic number. That is, the sum of the mass numbers on the product side must be equal to the sum of mass number on the reactant side. The same thing applies to the atomic numbers. As we have it in chemical reaction, we are going to have reactant side going forward into product side, going forward to the product side. So the sum of the atomic number of the reactant sides must be equal to the sum of the atomic number of the product side. Likewise, the atomic mass at the reactant side must be equal to the atomic mass for the product side. Let's look at an example under that for better understanding. Like the example on the board, 234 is the atomic mass. The atomic number is 90. And we have the element thorium. You have to find y and x, where you have beta here, which is 0 minus 1, which is an electron. So, the solution to this is the reactant side and this is the product side. 234 is equals to y plus O. Then y will be equals to 234 minus O equals to 234. We have gotten y. Similarly, where 90 equals to x plus minus 1. 90 equals to x minus 1. 90 plus 1 equals to x. X equals to 91. X, y, XPA will be equals to 234 91 PA. So we are getting y to be 234, yx equals to 91. Question 2 as an example. What is emitted during the disintegration of barium nucleus as shown by the equation below? 13856 barium gives 13454x. So we want to know what is there. That means something is missing here that we want to find. Solution. Solution. Since the atomic mass at the reactant side must be equal to the atomic mass at the product side, likewise atomic number at the reactant side must be equal to the atomic number at the product side. So that will be 138 equals to 134 plus what we don't know here. So that means we now have 138 minus 134 equals to box. So the box is equals to 4. Alright. So in the box here, we have 4 for atomic mass. That's for atomic mass. For atomic mass. Similarly, for atomic number, we are going to have 56 equals to 54 plus box. So make box the subject of formula. That means 56 minus 54 equals to box. So the box equals to 2. So for the atomic number, we have 2. For the atomic mass, we have 4. Hence, we have 4, 2. And which element has 4, 2? That is helium. Helium. So the answer for this bracket is 4, 2, H, helium. Is that understood? Alright. What is the element Y in the following equation? Solution. The sum of the reactant side must be equal to the sum of the product side for both the atomic mass and the atomic number. So that means for atomic mass, we are going to have 14 plus 4 equals to 1 plus, let's call this place Y and let's call this place Z. Let's call this place X. 1 plus X. So 18 minus 1 equals to X. X equals to 17. For atomic number, 7 plus 2 equals to 1 plus Z. 9 minus 1 equals to Z. Z equals to 8. So that means X equals 17, Z equals to 8. Then XZY will be equal to 17, 8Y. That is an isotope of oxygen, rather. That is an isotope of oxygen. So that is isotope of oxygen. Isotope of oxygen. How do we know that it is oxygen? The atomic number is 8. The atomic number is 8. And don't forget, for isotopy, it is the atomic mass that are different, while the atomic numbers remain the same. Example 4. We have 14, 7, n plus x gives 78 oxygen, 1 plus 1 hydrogen. Find x. Solution. For atomic mass, 14 plus, let's call this place W and N. 14 plus W equals to 17 plus 1. 14 plus W equals to 18. W is 18 minus 14. W is 4. For atomic number, for atomic number, 7 plus m equals to 8 plus 1. 7 plus m equals to 9. M is 9 minus 7. M is equals to 2. Hence, WMX equals to 42x, and that is helium. That is helium. That is helium. The last example on the board says balance the equations below. Balance the equations below. Don't forget that the atomic mass and the atomic number of the reactant side must be equal to that of the product side. 16 plus 1 here will give us 17. 12 plus 4 here will give us 16. That is not balanced. That is the efficiency of 1. 8 plus 0. 6 plus 2. The atomic number is balanced, but the atomic mass is not balanced. So which means if we are to balance that side, we are going to add neutron to this side. 1, 0. So we add neutron to that side. That is balanced. Balanced. Alright, we have 2 and 4, 83. Here we have 2 and 4, 84. Bismuth and polonium. The atomic mass is balanced, but the atomic number are not balanced. So, to balance that, what do we do? So that means we have to have 0 minus 1 electron. 0 minus 1 electron. So 214 plus 0 will give us 214. 84 plus minus 1 will give us 83. So this can also be, this is beta. 0 minus 1. Don't forget that beta is the same thing as an electron. Beta is the same thing as an electron. So it is balanced. Balanced. That is balanced. Let's consider nuclear fission and nuclear fusion. Fission has to do with splitting apart. Fusion has to do with joining together, coming together. So nuclear fission is a process in which a heavy nucleus spontaneously disintegrates into two lighter nuclei and several neutrons with with release of a large amount of energy. So what I'm saying is that when there is fission of nucleus of atom of an element, there will be a release of a fragment of that element. There will be a release of neutron and energy accompanying it. So for a natural fission, having uranium disintegrating, that will give us, we can have 235, 92 uranium plus neutron plus energy. So if we have 234, in the situation we have 234, 92 uranium, that will be plus 1 ON plus 1 ON plus energy. That is regarded as nuclear fission. Nuclear fusion. It is the combination of small atomic nuclei into larger ones with release of large amount of energy. So what I'm saying is that both nuclear fission and nuclear fusion will result into release of energy. For nuclear fission, nucleus of smaller elements, nucleus of atoms of smaller elements will combine together to give a larger one with the release of energy. Like the hydrogen here, deuterium plus deuterium, 2 plus 2 will give us 4. 1 plus 1 will give us 2 and produce a new element, which is helium with energy. So there is going to be release of large amounts of energy. The question on the board says, what does the following equation illustrate? 238 produce 23490, 42He, thorium and helium from uranium. What can we call this equation? You cannot call it nuclear fission. You can't call it nuclear fission because there is no production of neutron at the other side. You can't call it fusion because nothing is joining together at the reactant side. So this is disintegration. This is radioactivity. So this is radioactivity. That is disintegration. Disintegration of uranium-238-92 nucleus. That is the answer to that. Lastly, for today, we are looking at uses of radioactivity. Radioactivity can be used in the treatment of cancer, like gamma ray can be used. It can be used in archaeology for determining the age of material. The isotope of carbon is used. It can be used as a radio tracer in determining abnormality in the thyroid gland as radio tracers. Disadvantages of radioactivity. It can cause birth defects. That is why war is not encouraged. Using bombs, nuclear bombs. Exposure to that can cause birth defects in the next generation. Leukemia, cancer of the white blood cells. Exposure to radioactivity or radiation can cause leukemia, which is cancer of white blood cells. It can also cause other cancers. That brings us to the end of today's class. See you some other time.